Hello everyone, we are back at it again. Today we will be doing our A-Level paper 51 from October-November 2020. So let's have a look at the first question here. Okay, they were asking for two ordinary fair dice, one red and another one is blue, are thrown. So event A is that the score on the red dice is divisible by 3. While event B shows that the sum of the two scores is at least 9. So to get it done, things that you need to do will be writing this down. We have 1, 2, 3, 4, 5, 6. Okay, let's say this is for the red one, while this is for the blue one. We have 1, 2, 3, 4, 5, 6 as well. So as you can see, the keyword here that was set by the question is they use the word sum. So that's it for what we have, and then let's look at the special restriction that they wanted. First of all, they wanted the red dice to be divisible by 3. That would have all this here and here. Okay, because they are 3 and 6. Okay, it's not referring to the sum, but the 3 itself and 6 itself. And then the other one was that they wanted it to be at least 9, which means it must be 9 itself and above. So with all this set up, okay, we can now check the part that was overlapping. So that will be this 1, 2, 3, 4, 5. So our numerator will be 5, while our denominator will be 36, because there's 36 possible outcomes here. So that's your final results for part A. In part B, however, they were asking you whether or not these events are independent. So you have to check each of them individually. So our PA itself, that would make it a 12 out of 36, while our PB here will be those that was in the Tetris-like shape that I draw there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 out of 36. So by checking whether they are independent or not, all you have to do is to take PA times PB. So you have 12 over 36 times 10 over 36. You will get your results as 5 over 54, which it is not the same as what we gotten earlier. So that would make it not independent. Okay, so that's how you solve our question 1 here. So the next question that we have was assessing you on the probability that a student's a large music college play in a band was 0.6. For students who play in the band, the probability that she also swing a choir is 0.3. So first of all, if I were to list down the 3 diagrams of this, okay, in the band is 0.6. Not in the band will be 0.4. Out of those that is in a band, sing in choir will be 0.3. Okay, who does not sing in a choir will be 0.7. While if they are not in a band but still sing in a choir, that would make it X. Okay. and then doesn't sing in a choir will be 1 minus x. So these are the 4 scenarios that we could possibly get. Then let's check the last sentence here. They say randomly chosen does not sing in a choir is 0.58. So does not sing a choir will include our in a band but not in a choir, adding up with 0.4 times 1 minus x, and you get it as 0.58. So let's run the calculation and double check the results. You will get your x as 0.6. Okay, that's how you find your 0.6 here. So kindly take note, I shifted the 0.4, and also because of the relationship between negative 0.4 and x is multiplication, when I shift, the entire thing will be divided. Next question, 2 students from the college is chosen random. Both of them play in a band and both sing in a choir. So sing in the band and a choir, and then 2 of them. Okay, so just take 0.6 times 0.3, the results, and then you square it. You should get 0.0324 as your final answer. Okay, notice that there's no changes in denominator because they didn't give us exactly how many students were there. All they give us was the probability. So this is slightly different from what you learned back then in your mathematics. Okay, next question, we have question 3 here. Kayla is competing in a throwing event. A throw is counted as a success if the distance achieved is greater than 30 meters. The probability that Kayla will achieve a success on any throw will be 0.65. So they want you to find the probability that it takes more than 6 throws to achieve a success. So this is a trick question. Okay. They wanted more than 6 throws, which means all you have to do is to calculate the unsuccessful probability, that will be 0.75, and make it power of 6. So there's no calculation or details required here. You don't have to write 0.75 6 times, then times 0.25. You don't have to do that. All you have to do is to remember this question format is fixed. It comes up very often. All you have to remember is to take the other side of the probability and follow whatever inequalities that they use here. So they wanted 6 throws, we just put the power as 6. So the final answer should be 7294096, or approximately 0.178 if you were to write it in 3 significant form. But personally, I will prefer to leave it as a fractions because the data is more accurate basically. Part B, random sample of 10 throws, at least 3 successes. So what they are referring to is that you are calculating probability that is 3, 4, 5, 6, 7, 8, 9, 10. But to do that, it's too troublesome. So instead, you must use the reverse way, which is by taking 1, which is the total probability, minus off the probability of getting 0, getting 1, and getting 2. So when you write it down, okay, first of all, that will be 10C0. Okay. At least 3 success means no success at all. So our 0.25 will be to the power of 0 times 0.75 to the power of 10. Okay, repeat for The rest, we have 10C1, which makes a 1 successful throw and 9 not successive. And then the one last one, which is 2 success throw. Okay, through doing all this, you should be able to get your results. So the final answer for this will be, okay, 1 2 4 3 6 3 2 6 2 1 4 4, and if you were to make it into 3 significant figures, that will be 0.474 as your final answer. Okay, that's it for our question 3 here. Okay. Okay, please remember you can also do the one that I mentioned here, but it will be too troublesome. Okay, not that it's wrong or something, just that you must control your time more efficiently when it comes to our paper 5 here, because the duration is so short. Okay, next, question 4. Variables 1, 2, 3, 4, with a probability of 1/4, 2 independent values of x are chosen random. 2 values of x are the same. Okay, otherwise the y value is larger than the x. Okay, so I have no choice but to draw this out first, else it's too confusing. If the 2 values of x are the same, the random variables y takes the value. So we have 1, 2, 3, and 4. Okay. Otherwise, the y value is the larger value minus the smaller value of x. So it will be 1, this will be 2, this will be 3, this will be 1, this will be 1, this will be 2, followed by 2, 1, 1, and lastly we have 3, 2, 1, 4. So that should be the results. Find the probability of y. So there's only a few possible outcomes here. Okay, so this will be it. Our possible outcome will be 1, will be 2, will be 3, and also 4 here. And the probability of each of them is 1. There's how many of them? Let me double check. 1, 2, 3, 4, 5, 6, 7. 7 out of 16 of them. That will make it 7/16. 2 itself, we have about 1, 2, 3, 4, 5. 5 of them. That will make it 5/16. 3, there's only 3 of them. And lastly, 4 will be 1/16. So that's how you find the probability of each of the possible outcomes. So the main assessment here is whether you can read the question carefully or not and dissect the details part by parts on your own. Find the probability that y equals to 2 given that y is even. So p equals to 2, we already gotten it. That will be 5/16. The denominator will be assessing you on all the variables that is even number. So I shaded in blue, easier for you to understand. So we have 1, 2, 3, 4, 5, 6. 5 and 6. I accidentally colored the 3 there. So there's 6 of them out of 16 of them. So let's check the results. 5/16 divided with 6/16. So through this, you will get your final probability as 5/6. Next question, what we have here is a normal distribution question which means that we might have to check our Z table, okay, that was given in your formula sheet. So the time in hours that Darwin plays on his game machine every day is normally distributed with a mean of 3.5 and a standard deviation of 0.9. Okay, they wanted it to be more than 4.2 hours. So that's the key word here. So to find your final answer, all you have to do is to calculate the Z value by taking 4.2 minus our 3.5 and kindly divide it with your standard deviation. So 4.2 minus 3.5 divided with 0.9, you will get your results as 7/9. So this 7/9 here, okay, we have to check from the table. So the results of this should be 0.7778. Okay, I took 4 significant figures. Okay, so let's check our table now. So what we gotten was 0.7778. So you have to take like 0.7794 plus 0.0024. Let's double check how much was the value. 0.7794 plus 0.0024. That will make it 0.7818. So let's go back to our paper. So the exact value that we gotten was this. Okay, so we calculated that our Z equals to 0.7778. Okay, and then we gotten that it was approximately 0.7818 of them. But the key word here was that they wanted it to be more than, which means we must take the total probability minus 0.7818. And you get your answers as 0.2182 as your final answer. Okay, that's how you get your results here. It's easier always if you're able to illustrate out the graph there that I did over here. If your understandings towards how you handle Z value wasn't that strong. Okay. On 90% of the days, Darwin plays on his game machine for more than T hours. Okay, find the value of T. So what they gave us here was 90% of the days. So they gave us this straight away. It is 90%. So we have to check from our graph there and see whether we can find 90% or not. Okay, let's have a look here. Our 90% is actually somewhere around. So I noticed that the closest I can get was this from here and here. And I need to add about 4 to make it 90%. So that's why the final answer that I gotten was 1.282. Okay, so 90% it can either be plus minus 1.282, which I have to decide how am I supposed to get the results. Okay, Z value more than certain hours. Okay, minus of our 3.5 standard deviation divided with our 0.9, our standard deviation, and you will get your results as this. Okay, so time to run our calculation and check on what exactly should we choose. Okay, so if you reread the question, you will notice that instead of drawing what I have here, I should be doing this instead. Because they wanted 90% of the day. So I should shift this 90% to here. Okay, this is what they are referring to. So obviously, when you draw out the center line, where z equals to 0, it will help you to identify that the z value that we use here must be negative. So our t minus 3.5 over 0.9 will be equals to negative 1.282. So by taking negative 1.282, you multiply it with 0.9 and then plus 3.5 into it. And you will get your results as 2.3462. Which is approximately 2.35 lah, if you were to write it in 3 significant figures. Okay, so the main assessment here is after you read the question, okay, please draw it out. It will help you out a lot during the solving process. Okay, the keyword here was more than, so you must know that it is more than certain hours here. That's how I know the shaded part that they were referring to was on the right hand side. The first one that I draw is wrong is because that will cover I'm playing lesser than 90%. Okay, if I were to draw it like this, it is referring to the other side. 90% of the days I play less than certain hours. Okay, this is the wrong one, and the correct one will be here because they wanted the more than one. Next question, they want you to estimate the numbers of days of 365 days that he plays between 2.8 hours to 4.2 hours. So for this, I will have to calculate it again. 2.4 hours, 4.2 hours. We actually gotten the results from the start. Okay, because okay, never mind. So let's write it down first. What they were referring to was that they wanted 4.2 hours and 2.8. Okay, if you didn't notice that it was repeating from your question 1, okay, just treat it as per normal. Just calculate the z manually on your own. 4.2 minus 3.5 divided by 0.9. Repeat the same. 2.8 minus 3.5. 0.9. Okay, so from this, let's run the calculation. You will actually get z is between negative 0.778 to your 4.2 minus 3.5 divided by 0.9. You get 0.778. Notice why I say it was repeating after you look at the value. So what they wanted was they wanted the value in between this at the center. But actually we already identified how much was this 2 early on in our part 1. That will be our 0.218. Okay. So our 0.218 will be very helpful here because by taking 2 times 0.218, you should be able to get your results, which is 0.564 as your final answer. But kindly take note, they were referring to the amounts of days. So for this, you still have to multiply it with one last thing that we have. Okay, which is 365 days. You will get about 205 days. That's how I find the results here. Okay, let's look at question 6 here. They will ask us to draw a cumulative frequency diagram to illustrate the data. So let's say 20 is here. time taken. So let's finish the drawings for this part. Put in the zeros. They wanted until 150. Okay, so with this label out, we can now plot in all the points that we have. At 20 itself, it should be 12, which is somewhere around here. At 30, it will increase to 48. So each small box there is worth 2. Kindly take note on this. Each small box there is worth 2. So at 40, we arrived at 106. At 60, we arrived at 134. At 100, we arrived at 150. So the graph should look something like this then, if I were to draw it out. Okay, so this should be it. I couldn't quite draw it properly. I got no idea why. It just looks slightly off to me. Okay, so that should be it. Okay, this is the results that I'm gonna submit. Let's go on to the next question. They say 24% of the students take K minutes or longer to complete the challenge. Use your graph to estimate the K value. So instead of using the 24 that was given to you, what they were trying to ask is actually, if let's say this is the cumulative curve, they wanted those that took more than, okay, and then all those only carries 24%. So to trace the exact value, you should find out what's the balance here. That will make it 76%. So total students, there were 150 of them. So you multiply it with 76%. You will get 114. So from 114, let's check. 114 is somewhere around here, I suppose. So when we trace it down, you will get it as 40 plus minutes. I think it's about 44 minutes. Lastly, they want you to estimate the means and the standard deviation for the times to complete the challenge here. So this is one of the easiest because you're just following the formula, but the troublesome part was that there's a lot of work to do. So even if you follow the step-by-steps, if you mess up in part of the calculation, then you might lose the marks for the entire section. So let's calculate the mean first as per usual. Okay, to make your life easier, you must refer back to the tables that you have. Okay, that will be this. Okay. Kindly take note, for mean, we will be using half of the value. So 0 to 20, the midpoint of this is 10. So this one will be 20 to 30. The midpoint is 25. So 35, 50, and I think the last one will make it 80. And their respective frequency value is that. You have to minus it out. You have 36 here by taking 48 minus 12. So 106 minus 48, you will get this as 58. 134 minus 106, you will get 28, and the last one will be 16 by taking 150 minus 134. So the mean here will be by taking 10 times 12, adding up with 25 times 36, adding up with 35 times 58, adding up with 50 times 28, and 80 times 16. So all of them you will actually get 5,730, and you have to divide it with our total frequency, which is 150 here. So let me write it down first. So the entire thing divided with 150, you will get your answers as 38.2. This is for the mean only. So let's move on to calculate our variance. Okay, by identifying the variance and then square root it, you will get your standard deviation. Okay, so the only difference here was that all the x that we have, okay, we have to square it. Okay, so what we are doing here is actually for the group data. Okay, so the x, you're supposed to square it like I mentioned here. So all of this will be divided by 150, and then kindly remember to minus off the mean, but make sure you square it up. Okay, so let's run our calculation now. Yeah, I think I did wrongly. It should be 50 being squared. So please don't do the same mistake as me. Okay, and then the entire thing divided by 150, you will get 1781 minus 38.2 square. So you actually get 321.76. And then to get to your standard deviation, you have to square root the results. Then you will get it as 17.94. Okay, or 17.9 as your final standard deviation results. Okay, so this is what I meant by tricky. Make sure you use the correct formula and the correct variables. So moving on, we are at our last question here. Okay, the moment I read it, I know that this is actually a permutation question because of them giving us the full details and the letters here. And one more thing, the keyword that they used was arrangement or ways to be arranged. Okay, so they wanted 3 E's to be together. So out of the 10 letters there, so I draw 10 lines here underneath it. I group the 3's together. That will make it E's, E's, and E's. The rest, I just label a star and calculate how many stars can I put. So for the blank space, there will be 7, and then one more star is for the one that I grouped together. Okay, the purpose of doing this is because the e's they didn't mention it must be at the front or the back. So since it can be placed at any place, so we must label the star there to know how much should you multiply together. So to get to the results, there were 8 stars there. Okay, and then divide it with 3 factorial and 2 factorial. Then you get your answers of 20,160. Okay, in section B there, okay, find the numbers of different way which 10 letters can be arranged so that P's are not next to each other. So the keyword here was that they wanted the P to be not next to each other. Okay, so all you have to do is to know that how many letters that is not P here. We have about 10 minus 2, that would be 8. So I draw 8 circles first. 1, 2, 3, 4, 5, 6, 7, 8. And then the red part will be the numbers of position where I can put in the P's, which is in between the circles there. So we have 8P8 at first. Then I count 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9P2. This is for me to place the P's in. So 3 factorial is to represent the E's that was repeating, and 2 factorial is for the P. So 8P8 times 9P2. Okay, that is about 241,920. So repeat again, the circles is to represent those that is not P. That's a total of 8 of them. The red part that I put there was to represent the gaps, okay, that I can slot in the P. Okay, so 9P2, which means that is for me to slot in the P's, the 2 P's that I have only. Okay, moving on, we have question C. Find the probability that chosen arrangement 10 letters of the word shopkeepers with E at the beginning and E at the end. Okay, so they wanted us to find the arrangement first. They wanted E here and E here, which means I have 3P1 and then 2P1. The rest would just be 8P8. So 3P1 times 8P8 times 2P1 divided with 3 factorial and 2 factorial. Kindly take note, this is just for you to identify the possible arrangement, but it doesn't fulfill the question's requirement of identifying the probability. So you still have to get that done at the end. So that would make it 20,160. So the total probability, which is having no restriction at all, that will be our 10 factorial, which is you can simply arrange everything, or 10p10. Okay, divided with E's that is repeating and P that is repeating. So 10 factorial divided with 3 factorial and 2 factorial. You have a result of 302,400. So to find the probability, put these two against each other. (20160) divided with answers, you will get the results as 1/15. Okay, that's how you find the answer for section C. Lastly, we have our last question here. The keyword here was selected. So unlike the concept that you learned back then in AdMaths, okay, so when we try to rearrange this, okay, we have to set like include exactly 1 P only. So you have to focus on those that's repeating first. There can be 1 P and then 3 E, 1P2E with one random number, 1P1E with two random number, or P with three random number. Kindly take note, whatever that you set specifically, you don't have to consider about them. You don't have to calculate anything. Okay, this will just be 1. As for this, after excluding P and E, okay, you only have how many letters left? S, H, O, K, R. Okay, so the rest of the letters will include S, H, O, K, and R. So 5 of them, you just choose 1. 5 of them you choose 2, and 5 of them you choose 3. So let's run the calculation. So total, there will be 26 different selection. Okay, so I personally find this section D here harder for students to understand. Students might fall into the probability trap. Okay, so kindly read the question carefully. Then the other question that students might struggle to understand will be this from the cumulative frequency. Okay, read it carefully while you're solving it. The 24 students who take K minutes or longer, so those are referring to the one at the back. So to trace it back, you must use the 76%. So I get 76 by taking 100% minus 24. Okay, the other part that students might struggle to understand will be this from the normal distribution. Okay, read the question carefully because they say 90% of the days they spend more than certain hours playing games. So it is referring to the part that was above. Okay, then it's missing here. Okay, other than that, question 3A is quite tricky as well. Okay, kindly take note and remember how to solve this. The method to solve it was fixed. The rest is pretty straightforward. Okay, if whenever you encounter question regarding dice or whatsoever, please remember to draw out the table. It will help with your understanding a lot. Okay, so that's all for this paper. I would rate it a 8 out of 10 in terms of difficulty, but it's definitely a good paper to practice on. Okay, so that's pretty much it. I hope you find this video helpful. Okay, if you have friends that are struggling, feel free to share this to them, and I wish you all the best in your upcoming examination. Bye bye.